Have you ever stopped to think about what we humans are capable of when we all get together? I'm not talking about world peace or helping each other or any of that stuff. I'm talking about way more absurd but interesting things. Today, we're going to explore six completely crazy situations that would happen if all 8 billion human beings decided to do something together at the same time. What would happen if everyone slept at the same time for 8 hours? Okay, this question sounds ridiculous, but think about it for a second. Have you ever wondered why the world never stops? Well, it's precisely because we never all sleep at the same time. There's always someone awake somewhere on the planet doing something, whether it's working, watching Netflix at 3 in the morning because they can't sleep, or eating cereal straight from the box like nobody's watching. But anyway, let's imagine that somehow we managed to get all 8 billion human beings to fall asleep at exactly the same time for 8 hours. What would happen? First of all, absolute chaos. And I'm not exaggerating. Think about this. There are approximately 500,000 planes flying at any given time. If all the pilots fall asleep at the same time, well, you can imagine. We'd have 500,000 planes falling from the sky like metal rain. That's not even counting the millions of cars on the road, trains, ships, and that one guy who's always on his bike exercising at 5 in the morning like he's getting paid for it. But here's where it gets interesting. What happens with electricity? Turns out power plants need constant supervision. If everyone falls asleep, many of them would simply shut down automatically for safety. This means that when we all wake up 8 hours later, approximately 40% of the world would be without power. And we haven't even talked about nuclear plants. There are about 440 nuclear plants operating in the world. Some have automated systems that would put them in safe mode, but others, let's just say they need human supervision. In the worst case scenario, we could have between 50 and 100 plants in critical condition. Not all of them would explode like Chernobyl, but several would release radiation. Now, what about hospitals? There are approximately 18 million people hospitalized in the world at any given moment. If all the doctors, nurses, and even the janitor fall asleep, we're talking about between 2 and 3 million people potentially dying in those 8 hours from lack of medical attention. Pretty dark, I know. But wait, there's more. You know how many people need dialysis or are in surgery right now? Approximately 2 million people are on dialysis regularly, and at any moment there are about 500,000 surgeries happening. If everyone falls asleep, well, you know. And here's the weirdest part. Babies. There are approximately 385,000 babies born every day in the world. That's like 16,000 babies per hour. In 8 hours, that would be 128,000 babies trying to be born while their moms are asleep and the doctors are snoring. Nature would take its course, but many would definitely need help. But now comes the interesting part of the adjustment. What would happen if instead of everyone sleeping at exactly the same time, we organized ourselves so the world could keep functioning? Think about it like this. If we divide humanity into 3 8-hour shifts like a giant factory, we'd have approximately 2,667,000,000 people awake on each shift. That's enough to keep things running. The first shift from midnight to 8 in the morning would handle power plants, emergency hospitals, and basic services. The second shift from 8 in the morning to 4 in the afternoon would handle most daytime activities. The third shift from 4 in the afternoon to midnight would close the cycle. If we do it this way, the world wouldn't just keep functioning, we'd actually be more efficient. There'd be less traffic, less pollution, and interestingly, we'd consume less energy because only a third of the lights would be on at any given time. The calculations show this would reduce global energy consumption by approximately 25%, which is impressive. That means we'd emit 8 billion tons less CO2 per year. But of course, the original question was what would happen if everyone slept at the same time? And the answer is still An absolute disaster that would kill millions and leave the planet half destroyed. But hey, at least we'd all sleep well that night, right? Okay, let's move on to the next question because this gets even more interesting. What would happen if we all jumped at the same time? This is the classic thought experiment everyone's thought about at some point. Usually when someone mentions it to you for the first time, you think, oh yeah, we could probably destroy the planet or we could knock it out of orbit, but reality is way more interesting and disappointing at the same time. First, let's do the numbers because numbers are fun, said no one ever, but whatever. 8 billion people with an average weight of 62 kilograms, because you have to count babies, kids, and all types of people, gives us a total weight of 496 billion kilograms. Sounds like a lot, right? Well, I've got news for you. Earth weighs 5.972 times 10 to the 24th kilograms. To help you understand, if Earth were a soccer ball, all of humanity together would weigh less than a grain of sand. In fact, we'd weigh like 0.000000000000001% of Earth's mass. In other words, we're irrelevant in terms of mass. But anyway, let's say somehow we managed to get everyone together in one place. We already saw in the previous case that we'd fit in an area the size of New York and we all jump 30 centimeters at the same time. What would happen? When we jump, we push Earth downward with our weight. By Newton's third law, every action has an equal and opposite reaction. Earth also pushes us upward. So far, so normal. But here's where it gets interesting. When we're in the air, Earth effectively moves upward. Because we're no longer pushing it down with our weight, we displace it approximately 0.0000000000001 meters. That's less than the radius of a hydrogen atom. And then when we all fall to the ground at the same time, we push Earth back down with the same force, completely canceling out the previous movement. So the net effect is exactly zero, nothing. Nothing happens. But wait, what about the sound? That's where something interesting happens. 8 billion people falling to the ground at the same time from 30 centimeters high would generate approximately 200 decibels of sound at the point where we're all gathered. To give you an idea, 200 decibels is enough to burst eardrums and cause permanent damage. In fact, it's roughly the sound level of a rocket launching. But here's the cool part. If you're 100 kilometers away, you'd only hear a dull thud of about 60 decibels, like the sound of a normal conversation. Sound disperses and weakens with distance. Now comes the chaos adjustment. What would happen if instead of jumping all at the same time, we organize ourselves to jump in sequence? Imagine this. 8 billion people lined up in a giant line around the equator, which measures 40,075 kilometers. If we space ourselves evenly, there'd be one person every 5 meters. If the first person jumps and then the next person jumps exactly when the first one lands and so on, we'd create a wave of jumps that would travel around the world. If each person jumps at the exact moment the previous person lands, approximately 0.5 seconds per jump, the wave would travel at 10 meters per second, or 36 kilometers per hour. This means the wave of jumps would take approximately 1,113 hours to go around the world. That's 46 days of continuous jumping. But here's what's truly crazy. If we could coordinate this perfectly, we'd create the longest mechanical wave ever created by humans. And even though we wouldn't move Earth out of its orbit, the spectacle seen from space would be absolutely epic. Plus, if we synchronize the jumps to match the resonance frequency of Earth's crust, which is approximately 0.3 hertz, we could technically cause a detectable micro earthquake. It wouldn't be dangerous, but seismographs around the world would detect it. So yeah, we can do something interesting by jumping, but destroying the planet or moving it out of orbit isn't on the menu. Sorry for ruining your supervillain dreams. But now let's go with something that actually could collapse something important in the modern world. What would happen if we all sent a text message at the same time? Okay, this is a good one. We're living in 2026, and we're all glued to our phones like they're extensions of our arms. In fact, you're probably watching this on your phone right now while ignoring someone who's talking to you. I don't judge. I'd do the same. But anyway, what would happen if all 8 billion human beings, well, about 5,500,000,000 who have access to mobile phones, decided to send a text message at exactly the same time? First, a little context. Currently, about 23 billion text messages are sent per day worldwide. That's like 266,000 messages per second. Telecommunications networks are designed to handle traffic spikes, but they have a limit. The maximum SMS message processing capacity of global networks is approximately 2 million messages per second. This sounds like a lot, but if 5,500,000,000 people send a message at the same time, do the math. 5,500,000,000 messages in 1 second versus a capacity of 2 million per second. We're trying to shove 2,750 times more messages than the system can handle. The result? Total collapse, but not just that. Here's what would happen on a timeline. First, from 0 to 10 seconds. Cell towers would try to process all the messages at the same time. Most would fail immediately and enter a queue. Your phone would say sending and just stay there, like when you try to send a message in the subway with no signal. From 10 to 60 seconds, towers would start to overload. Many would simply reboot automatically for safety. Others would enter emergency mode where they only allow emergency calls. From 1 to 5 minutes. Approximately 80% of cell towers in the world would be down or rebooting. This means you wouldn't just be unable to send messages, you couldn't make calls, use mobile internet, or do anything with your phone except play Snake. If your phone had Snake, which nobody has Snake anymore, and that's sad, from 5 to 30 minutes, towers would start to slowly recover. Messages in the queue would start sending, but chaotically. Some would arrive, others wouldn't. It'd be like when there's a natural disaster and the lines collapse. From 1 to 6 hours. Gradually, the system would normalize. The last messages would send. But in total, approximately 40% of messages would be completely lost. But here's what's really interesting. The economic impact. The global telecommunications industry generates approximately $1.8 trillion per year. If the system goes down for 6 hours, we're talking about losses of approximately $1,230,000,000. And not just that. Think about all the things that depend on phone networks, mobile payment systems, goodbye to paying with your phone, two-factor authentication systems. You won't be able to log into any app. Emergency services, this is the most dangerous. Vehicle tracking systems, Internet of Things, all your smart devices would stop being smart. Okay, but what would happen if instead of sending all messages at the same time, we send them in an organized way to not collapse the system? If we divide the 500,000,000 users into groups and each group sends their messages 1 second apart, we'd need 2,750 seconds or approximately 46 minutes for everyone to send their message without collapsing the system. But there's a cooler way to do it, the message wave. Imagine we start in New Zealand because they're always first in everything due to time zones. Everyone in New Zealand sends their message. 1 second later, everyone in Fiji sends theirs. 1 second later, Australia, and so on, following the time zones around the world. If we do it this way, creating a wave of messages that travels around the planet following the sun, it would take exactly 24 hours to complete the circle. And not only would we not collapse the system, we'd create the largest synchronized communication event in history. Telecommunications companies could monitor this wave of messages moving around the planet in real time. It'd be like watching a physical wave, but made of data. And the best part, if we all send the same message, for example, hello world or did you subscribe to the channel yet? We'd create a historical record of the moment when all of humanity communicated as a single entity. Philosophically speaking, it would be the first time in history that literally all humans say the same thing at the same time. That's pretty profound if you think about it. Now, what if we tried something geometrically interesting? What would happen if we all formed a giant octagon? Okay, this question is random, but I love it because it's absurd and mathematically interesting at the same time. First, why an octagon? I don't know. Maybe because stop signs are octagons and we want to send a message to the universe to stop expanding or something. Or maybe just because octagons are cool. But anyway, let's do the math because math doesn't lie. If 8 billion people hold hands with 1 meter of distance between each one, we'd have a perimeter of 8 billion meters or 8 million kilometers. To calculate how much each side of the octagon measures, we simply divide the perimeter by 8. So 8 million kilometers divided by 8 gives us 1 million kilometers per side. Each side of the octagon would measure 1 million kilometers. To give you an idea of how big this is, the distance from Earth to the moon is approximately 384,400 kilometers. The sun's diameter is 1.39 million kilometers. Each side of our octagon would be almost as long as the sun's diameter. And now comes the cool part. How much would the octagon measure from corner to corner? Without getting into complicated formulas, the distance between opposite corners of a regular octagon is the side multiplied by 2.414. So 1 million kilometers times 2.414 gives us 2,414,000 kilometers. That's more than 6 times the distance from Earth to the moon. In fact, our octagon would be so big, we could fit the moon's orbit inside several times. All of Earth's communication satellites, the International Space Station, although it's relatively close, and we'd still have room to fit like 3 more Earths. But here's what's truly interesting. What about the corners? In an octagon, each corner has an internal angle of 135 degrees. This means the people at the corners would have to be in a slightly awkward position, not completely stretched in a straight line, but at an angle. If you're at a corner of the octagon, the 2 people next to you would be forming a 135-degree angle with you. There'd be 8 corners, which means 8 people in special positions. Now, how long would it take to form this octagon? If we assume people can move at an average walking speed of 5 kilometers per hour, and we start from everyone bunched up at one point and expand outward, well, the people who end up at the furthest corners would have to walk approximately 1,207,000 kilometers, which is half the diagonal. At 5 kilometers per hour, that would take 241,400 hours, or approximately 27 and a half years of walking nonstop. Okay, that's not practical. Here's the problem with the adjustment. Earth's perimeter at the equator is only 40,075 kilometers. Our octagon needs 8 million kilometers. That means the octagon would be 200 times bigger than Earth. It doesn't fit. It literally doesn't fit. But what would happen if instead of making one giant octagon, we make many small octagons distributed all over Earth? If we divide the 8 billion people into groups of 1 million, we'd have 8,000 separate octagons. Each octagon would have a perimeter of 1 million meters or 1,000 kilometers, and each side would measure 125 kilometers. Is this more feasible? Yes. We could distribute these 8,000 octagons all over the planet. If we space them evenly, there'd be approximately one every 63,875 square kilometers. If all these octagons form at the same time and are all oriented in the same direction, let's say with one side pointing north, from space, it would look like a giant geometric pattern covering the entire planet. It'd be like Earth had an octagon disease, or like someone had tiled the planet using octagons instead of tiles. From the International Space Station, depending on the curvature and your position, you could see between 5 and 20 of these octagons at the same time. It would look absolutely surreal. And if we all used lights or reflective clothing and do it at night, we'd basically turn Earth into a giant disco ball with an octagon pattern. What would this be good for? Absolutely nothing. Would it look cool? Absolutely yes. Is it worth the effort? Probably not, but since when has that stopped us? Now, speaking of things we all share without realizing it, what would happen if we all breathed the same air at the same time? Okay, this question is a trick because technically we're all already breathing the same air all the time. Air mixes, circulates, and we all share the same atmosphere. The air you just inhaled probably contains molecules that were once in Cleopatra's lungs, Einstein's, or that guy you met at a party and never saw again. But let's interpret this question in a more interesting way. What would happen if we all inhaled at exactly the same time and then all exhaled at exactly the same time? First, the numbers, because we already know I love numbers. An average human inhales approximately 0.5 liters of air per breath at rest. When you're calm, not when you just climbed stairs because you forgot the elevator exists. 8 billion people times 0.5 liters gives us 4 billion liters of air. That's 4 million cubic meters of air. To give you an idea of how big that is, a typical large stadium has a volume of roughly 2 million cubic meters. Our simultaneous inhalations would equal the volume of about 2 full stadiums of air. Now, Earth's atmosphere contains approximately 5.15 times 10 to the 18th kilograms of air. In volume, that's approximately 4.2 times 10 to the 9th cubic kilometers of air at sea level. If we convert the 4 million cubic meters we inhale to cubic kilometers, it's 0.000004 cubic kilometers. In other words, literally nothing. We wouldn't affect the atmosphere one bit. But, and this is a big but, what would happen locally? If we're all in the same place, remember we fit in an area the size of New York, then locally we would create an effect. When we all inhale at the same time, we'd create a momentary low pressure zone. Air from the surroundings would rush to fill that void, creating a sudden wind directed toward the center of the crowd. If we're all in an area of 1,000 square kilometers, roughly the size of New York, and suddenly inhale 4 million cubic meters of air, we'd create a pressure drop of approximately 0.004 millibars. That doesn't sound like much, but it would be enough to create a wind of approximately 2 to 3 kilometers per hour directed toward the center. It's not a hurricane, but you definitely feel a breeze. And then when we all exhale at the same time, the opposite would happen. We'd create a high pressure zone and the air would rush outward. Another wind of 2 to 3 kilometers per hour, but this time moving away from the center. If we coordinate this and do rhythmic inhalations and exhalations, we could create a pulsating wind pattern. It'd be like the city was breathing. Now comes the interesting part. What would happen with CO2? When we inhale, we take air with approximately 0.04% CO2. When we exhale, that air contains approximately 4% CO2. That's 100 times more concentration. If we all exhale at the same time, we'd release approximately 160 tons of CO2 in a single second, based on each person exhaling approximately 20 grams of CO2 per breath. In the New York area where we all are, the CO2 concentration would momentarily increase from 400 parts per million to approximately 800 parts per million. 800 parts per million isn't dangerous. You'd need like 5,000 parts per million to start feeling bad, but it is double the normal amount. If you're in the center of the crowd, you definitely feel the air is heavy or stale. And here's what's crazy. If we could measure this from space, which we can't, but let's imagine we could, We'd see a cloud of CO2 expanding from New York every time we all exhale. The chaos adjustment would be this. What would happen if instead of all breathing at the same rhythm, we breathe in synchronized waves to create a pattern? Imagine this. We divide humanity into 4 groups of 2 billion each. Group 1 inhales while Group 3 exhales. Group 2 inhales while Group 4 exhales. And we alternate. If we do this, we'd create a constant flow of air moving in a specific direction. It'd be like creating an artificial air current using only our lungs. If we're all in the same place and coordinate this perfectly, we could create a sustained wind of approximately 5 to 10 kilometers per hour in whatever direction we want. What would this be good for? Well, if it's really hot, we could create our own breeze. If someone farts, we could direct the air away from us. The possibilities are endless but useless. But here's the most interesting application. If we all breathe at the same rhythm and frequency, we'd create a pressure wave that would propagate through the atmosphere. If we breathe at exactly 0.01 hertz, one breath every 100 seconds, which would be super slow and weird, we could create a pressure wave detectable by barometers around the world. It wouldn't cause any damage or change the climate, but it would be the first time in history that humans created a detectable signal in the atmosphere using only our bodies. Future scientists would study this event as the Great Breath of 2026 and would write papers about how humanity coordinated their lungs to create the largest respiratory event in history. And to close with a bang, let's go with the most interesting question of all. What would happen if all humans decided to stay silent for 24 hours? This is probably the most interesting question of all because it has implications that go way beyond the obvious. Think about it. Never in the history of humanity have we all been completely silent at the same time. Never. There's always someone talking, yelling, singing, crying, laughing, or making some kind of vocal noise somewhere in the world. We're noisy by nature. But what would happen if somehow we managed to get all 8 billion human beings to keep complete silence for 24 hours? The first 6 hours would be the weirdest thing in the world. Imagine waking up and absolutely nobody is talking. There are no newscasters on the radio because the presenters would be silent. No YouTube videos with narration, no phone calls, no teachers giving classes, no salespeople offering things, just silence. The first thing you'd notice is that suddenly you can hear sounds we normally ignore. The humming of refrigerators, the ticking of clocks, the wind moving leaves. Traffic would feel different because even though cars make noise, there'd be no honking, no people yelling at each other, no music coming out of windows. But here's what's interesting. What happens with jobs that depend completely on talking? Call centers would have to close. That's approximately 17 million people worldwide who work in call centers. Teachers couldn't teach. That's 70 million teachers in the world. News anchors, radio hosts, actors, singers, all would have to stop. In fact, approximately 30% of all jobs in the world depend directly on verbal communication. We're talking about 1,200,000,000 people who couldn't work during those 24 hours. The economic impact would be approximately $350 billion in losses just for one day. But here comes something deeper. What happens with our mental health? Humans are social animals. We need to communicate. Studies show that social isolation and lack of verbal communication can cause stress, anxiety, and even symptoms of depression in periods as short as 12 hours, in 24 hours. Of complete silence, approximately 20% of people would experience significant levels of anxiety. That's 1,600,000,000 people feeling bad just from not being able to talk. Children would be the most affected. Babies cry to communicate. If they're silent because somehow we force them to be, parents wouldn't know if they're hungry, if something hurts, or if they need something. This would be dangerous. In fact, in 24 hours of total silence, it's estimated that approximately 50,000 babies and young children could die who needed to communicate a medical emergency but couldn't. Now, what about emergencies in general? Emergency services depend on calls. If nobody can talk, nobody can call 911 or their country's emergency number. If someone has a heart attack, an accident, or any emergency, they couldn't ask for help verbally. They could use text messages, yes, but the response would be slower. It's estimated that in 24 hours of a silence, deaths from emergencies that couldn't be communicated in time would be approximately 100,000 more people than normal. But here's what's fascinating from a sound perspective. What would the world sound like without human voices? The average city has a noise level of approximately 70 decibels during the day. Human voices contribute approximately 20 decibels to that total. If we remove all voices, urban noise level would drop to approximately 50 decibels. 50 decibels is the noise level of a quiet office or a soft conversation. Cities would feel strangely quiet, but not completely mute. You could hear things you normally don't hear. The sound of your own footsteps more clearly, the wind, birds that are normally drowned out by human voices, the sound of water running through pipes. It'd be like the world hit pause on the human soundtrack, but left everything else playing. And here comes the chaos adjustment. What would happen if instead of keeping complete silence, we establish silence zones and speaking zones? Imagine we divide the day into shifts, just like with sleep, 12 hours of silence, 12 hours of speech. During the 12 hours of silence, only written communication, sign language, or nonverbal communication is allowed. This would have interesting benefits. First, we'd learn to communicate in other ways. Sign language would become more common. Written communication would improve. People would pay more attention to nonverbal communication like body language. Second, ambient noise would be significantly reduced during those 12 hours. This would improve sleep quality for millions of people living in noisy cities. Studies show that nighttime noise reduction can improve sleep quality by up to 40%. Third, there'd be a positive psychological impact. People would value words more when they can speak. Communication would be more intentional, more careful, maybe even more honest. But of course, going back to the original question of 24 hours of complete silence, it would be fascinating, terrifying, dangerous, and probably something we should never attempt. However, the idea that all of humanity could coordinate something like this, even for just one day, makes us think about our capacity to work together when we really decide to. And well, that brings us to the end of this journey through 6 completely absurd but fascinating scenarios about what would happen if all humans did something at the same time. We learned that if we all sleep together, the world collapses. If we all jump together, nothing happens, but it'd be cool to see in slow motion. If we all send messages together, the internet crashes. If we make octagons together, we have to make them small because we don't fit in space. If we breathe together, we can make wind with our lungs. And if we all shut up together, the world becomes strangely calm, but also dangerous. The moral here is simple. Humans are powerful when we coordinate, but we're also fragile when we do things without thinking. Our world works because we're desynchronized, because each person does their part at different times. But hey, it would be incredible if we could coordinate something massive someday, something that doesn't destroy anything, but does prove that when we want to, we can work together. In the meantime, make sure to subscribe to the channel for more absurd thought experiments like these. Hit that like button if you made it this far, because that means you stuck through the whole thing. And leave me in the comments which of these scenarios you'd like to see in real life. And remember, don't try any of these at home. Or, well, yeah, but tell your neighbor first. See you in the next video. Goodbye.